Hi, Calculus 1 students. So we are in the section of derivatives of logarithmic functions. And this video is about this example. So we're given a function of x that has a ln of x inside, okay? And we want to find a pattern. So y, the 21st derivative of y. Okay. So I think with the assignment, you built up experience with that kind of problem. However, you shouldn't go too fast, right? You should still take both of these terms and make a couple of derivatives to see what the pattern could look like. So first, let's take x ln of x. Why not? Okay, so let's start with the first one, and then we'll do the second one, obviously. Okay. So, and what's nice to see here is that the first derivative is going to give something different than all the rest. Because for the first derivative, you have to use the product rule. So you know the product rule very well already, but since I like color coding, 1 ln of x plus x times the derivative of ln of x, which you know by now very well is 1 over x. So simplifying this will give you ln of x plus 1. Okay. So not an obvious pattern yet, but you have to keep pushing, right? So you're going to take now the second derivative, which is going to end up being 1 over x. And at this point, we have seen a pattern for 1 over x. So we know that we're going to write it as x to the negative 1 to take the next couple of derivatives. Let's take two more to see like how it works out. So if we take a third derivative, okay, we're going to get negative 1 x to the negative 2. And if we take a fourth derivative, so not long at all to do, but it's just to comfort us in our pattern. Negative 1, negative 2, x to the negative 3. And let's just write this one down in a suggestive way, okay? So you know that you have two negative signs. So let's write here negative 1 to the power of 2. Even though this is positive 1, it's actually nice to write it like this because it helps us find our pattern. And then we have we have 2 factorial, and we know that if we take another derivative, we're going to drop a negative 3, so we're going to have 3 factorial, and then multiplied by x to the negative 3. So remember, what you have to do at this point is to compare the number. So we have to compare, so we're taking the fourth derivative, and we have 1 squared, we have 2 factorial, but we have x to the negative 3, okay? So in other words, if we take n derivatives, so x ln of x, if we take n derivative instead, so what will happen is we will have negative 1 to the power of, and instead of 2 here, we will have n minus 2, okay? Then we will have n minus 2 factorial multiplied with x to the power of, and instead of 4, we have 3. So we're going to put the negative here, and n minus 1. That you can also write as 1 minus n, but it's not my suggestion, because if you do that, you still might make a mistake in your pattern. It's much clearer if you say, take the negative of the number right before n. And from there, obviously, replacing n with 21, which actually you can do without writing this out, right? You can actually do it straight from the previous step. But training yourself in writing this is actually a good thing. Okay, so to the power of 21. This means that n minus 2 is 19. And it means that this factor right here, let's color code it in purple. This factor right here will turn out to give you a negative. Then this n minus 2 factorial will give you 19 factorial. And finally, this, that's it. So this x to the negative n minus 1 will give you, oh, I will keep the color code in orange this time around. So this x to the power of negative n minus 1 will give you x to the power of negative 20. So this is the first term. The second thing to do is to work with the next term. So just the 2x to the 2x minus 1 to the 21. Okay, and here it's much easier to see what will happen because it's what I like to call a general power rule. We're gonna decrease the exponent each time by 1 and multiply by the derivative of the inside function, which every time is going to be 2. So I think if you take even just 2 derivatives, you should be able to see the pattern very well. Okay, but let's still do it. So if you take a first derivative, you'll get, and then I'll suggest some colors over here. So 21 times 2x minus 1 to the power of 20. And then you're going to have the 2, right? The derivative of the inside function, which is just 2, okay? Take note here that I don't color code the derivative the same way as usual because I want to draw your attention on the pattern that's emerging. Now, if you take another derivative, okay, so the second derivative, here's what will happen. You still have this 21, but now it's going to be accompanied by the 20 that drops down. The exponent of 2x minus 1 will decrease by 1, so it will become 19. The 2 is going to be there, but it's going to be accompanied by another 2. Okay? So this is probably enough for you to realize that the 21st derivative, okay, so first of all, the 21st derivative, I remind you, won't be 0, but it will be a very simple constant. Okay, so the 21st derivative, we're going to have 21, 20 until 1. And if you like to think it this way, times x to the power of 0, but I prefer just saying that the derivative of x is 1. But that's it. You'll have all the numbers from 1 to 21. In other words, you'll have here 21 factorial. Okay, so this is what the green will end up being. And then, since you're taking 21 derivatives and you get a factor of 2 every single time, you're going to multiply this 21 factorial by 2 to the power of 21. So, you've got your result right there. So you're going to have that, this is it, like the 21st derivative of y is going to be the sum of this. Okay, so I'm going to use, yeah, well, I mean, yeah, that's, okay, I'll use the same color code, but I shouldn't because it's, or no, I have an idea. I'll write it in, I'll just like underline them in black. And I just want you to see that we're just taking the difference of these. So negative 19 factorial x to the negative 20, okay, minus, okay, so the minus that's at the top, I'm not going to color code it, and this one, so 21 factorial times 2 to the 21. All right, this is it. See you in class or in the next video.